Hi everyone, welcome to the second part of our lesson on perpetuities and annuities. In the first part we covered perpetuities. There's a link in the video description. If you haven't watched that part yet, you can watch that first. And now in the second part of this lesson, we'll be talking about annuities.
Right? So annuities as well are special streams of cash flows. So how do they differ from perpetuities, right? So in the case of a perpetuity, we had a fixed cash flow that kept recurring, right, indefinitely. The difference in the case of an annuity is that we again, in let's say a regular annuity, we again have regular intervals and the same constant amount of cash flow, but at some point it stops. So it has a finite maturity. So let's say in this case we stop it in year 4. So this will be a 4-year annuity. So there are no cash flows afterwards, right? Whereas with perpetuities, it kept going and going. Okay. So what could be an example of an annuity? Think of your mortgage payments, for example. If you own a house and if you bought it with a mortgage, you are making basically mortgage payments to your lender. Typically on a monthly basis, and this is a fixed term, right? Might be 30 years or 20 years. So once that period is over, you won't make any more payments. So your mortgage is going to be fully paid, right? So that's a good example of an annuity. Or similarly, any loan repayment schedule can be thought of as an annuity. Another good example would be, for example, corporate bonds. So they, or coupon bonds in general, so they will make regular coupon payments, and at some point the bond will mature and it will pay back its face value. So that's the actually next example we'll be looking at. Now the question, of course, is what's going to be the present value of the regular annuity. So in this case, the formula is slightly more complicated, but not a lot, trust me. So in this case, the formula will be C over R, which is actually the perpetuity formula, minus C over R, 1 plus R to the power T, where T is basically the duration of the length of the annuity. And the logic is actually quite simple, because an annuity, so this is our annuity, is like the difference between two perpetuities. One starting now, so the whole thing, minus the one starting at this point. So if you take the difference, then you get the present value of the annuity formula. But of course, this is for a regular annuity. Let's look at the present value of a growing annuity as well. So in this case, first let's look at the cash flows. Again, we start with a cash flow of C. Then it will be C times 1 plus G. C times 1 plus G to the square. And let's say, again, this is a 4-year annuity. So the final cash flow will be C times 1 plus G cubed, okay, raised to the power 3. So what will be the growing annuity formula? Of course, like in the case of a growing perpetuity, we'll need to take into account this growth rate. So we can write the formula as present value for growing annuity equals to C R minus G. Again, this is the growing perpetuity formula, of course. And again, we are going to take the difference between two growing perpetuities. So this is CR minus G. And we will have an additional term here, 1 plus G divided by 1 plus R to the power T. Again, T, for example, in this case is 4. It's the length of the annuity. So actually, this is the most general formula, and all of the formulas are special cases of this. For example, if G is 0, so basically if you put 0 here, if you put 0 here, and 0 here, we have exactly the same formula as above. So if G is 0, this growing annuity becomes an ordinary annuity. And if T goes to infinity, so for example, if T goes to infinity, essentially this whole term goes to 0, and we are left with the perpetuity formula, okay? But if you want to find the present value of a growing annuity, this is what you need, okay? And sometimes you might need to find the future value of an annuity. That's quite easy to find. So future value meaning basically at the end of the annuity, right? So let's say you have these regular cash flows, and at year 4 you want to find the future value. All you need to do is basically compound the present value by 1 plus r to the power t, right, which is the length of the maturity. So for example, if I multiply everything with 1 plus r over t, I get rid of this term, and then there's a factor of 1 plus r over t here, and the same in this case as well. Now let's look at one example of how to apply this formula, and this is from a bond valuation exercise. So we have a coupon bond, okay, and this will make regular annual coupon payments of $20 for the next 5 years, okay, and it has a face value of 1,000. It's always useful to write these cash flows. Okay, so we have 0, 1, 2, 3, 4, and 5. So each year we will get a coupon of $20 for 5 years. So this is really the annuity part. But of course, when a bond matures, you get back the face value as well. So we'll get an additional $1,000. And the question is, what's the current price of the bond? All we need to do is to find the present value of these cash flows, and that will be the value of this bond. So basically, we need to compute two things. This annuity part, so it's a 5-year annuity. So remember our general, oops, I thought I lost the cursor. Okay, so this is our general annuity formula. So here our cash flow is 20, okay. Our discount rate, so we need to use what we call the yield to maturity. So this is basically the return you will get from holding this bond by holding it until the end. So it's like an internal rate of return for bond pricing. So this is 0.05. So this is the R here, minus 20, 0.05, 105, right? 1 plus 0.5, 105 to the power 5. Why? Because the duration of the annuity is 5 years. So this is the annuity component, but I have one final cash flow, the face value that I will receive at the end, and the present value of that, again, I'll need to discount it back 5 years, okay? So we have an annuity calculator on the same page on our website as well. The link is in the video description. Feel free to check that out. So basically, using that calculator, you can find that this is going to be $86.59. And we have a present value calculator on our website as well. If you use it, this you can get as 783.53. And if you add them up, the price of the bond today is $870.12. Okay, so we would say that because this is less than $1,000, this bond is trading at a discount. Okay, here is a quiz for you to test your learning. A couple of true or false questions. The link to the solutions is in the video description as well. It's basically the same page where we have the calculators. So have a look at these questions and see if you can answer them correctly. And this is going to be it for this second lesson. In the next lesson, we will move on to another important topic, which is the net present value. I hope you have enjoyed this lesson from our Principles of Finance course, and looking forward to see you again in the net present value lesson. Bye for now.